Hey guys, in this video we're doing lesson 6.5, which is on factoring polynomials. And there's a lot to this, and we're actually only going to do the first part in this video. And so we'll stop about halfway through. And some of this you may be familiar with, some of it maybe not. So just bear with me, and we'll get lots of practice in over the next few days. So hopefully you'll get pretty good at it. So the first thing is kind of extremely important. It's the GCF. A lot of times you will do the GCF. You'll take out the GCF, and then you'll have more factoring to do. And taking out the GCF typically makes your factoring problem look a little easier because it takes out, makes the numbers smaller and takes out some of the stuff. So when you're looking at the GCF, you got to look at both the coefficients, those are the big numbers in the front, and the variables. So think about 12 and 10. What is the largest number that goes into both 12 and 10? That number is 2. And then look at the variables. I have x cubed and x squared. We want to take out as many x's as we can, but we can't take out more than something has. So for example, I couldn't take out 3 x's because this one over here only has 2. It only has x squared. So we can only take out x squared. And then we have to figure out what we're left with. Well, if I divide 12 by 2, I get 6. And then I'm left with an x plus 10 divided by 2 is 5. And I took out all of the x's, so there's none left. Number 2, 14 and 7. What is the largest number that goes into both 14 and 7? It's 7. And then m's, I can take out 2 m's, so m squared, and n to the 5th. 14 divided by 7 is 2. And then for the m's, I have 6 left. And I took out all of the n's from that first term. Minus 7 divided by 7 is 1. You don't have to put the 1. I took out all of the m's, and I'm left with 4 n's. Now, the next type of factoring is difference of squares. This is where we have 2 perfect squares that we are subtracting in the middle. And you need to know your perfect squares. So go ahead and list out the first 12. That should be good. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. That's all that's going to fit, so I'm going to stop there. So those are all numbers that are perfect squares. What about variables? So variables with an exponent that's divisible by 2. So if you have a variable with an exponent that's divisible by 2, it's considered a perfect square. So for example, if I want to take the square root of x to the 8th, you divide the exponent by 2. That would be x to the 4th. The square root of x squared, 2 divided by 2, is 1. So we would have x to the 1st power, or just x. What about the square root of x to the 16th? That would be x to the 8th. So now let's go back and look at how we actually factor difference of squares. So let's say we have a squared minus b squared. So we have two perfect squares and we're subtracting. When we factor, we get a plus b, a minus b. So we take the square root of each side, and then we have a plus b, a minus b. All right, so when we're solving these, we take the square root of each part. 9x squared, that's 3x, and the square root of 49y squared is 7y. And then we write our answer as 3x plus 7y, 3x minus 7y. Number 4. This one has a GCF because 72 and 2 are both divisible by 2. So we have to take out that 2, leaving me with 36 c to the 4th minus 1. Another thing that would make me think, oh, there's a GCF, 72 and 2 are not perfect squares. I couldn't have taken the square root of them. So that was my hint that I probably needed to find a GCF. So the square root of 36 c to the 4th, that is 6 c squared. If I take my exponent of 4 divided by 2, we get 2. So that's where the c squared came in. And the square root of 1 is 1. Now when I write my answer, we have to make sure we include the GCF. Then we have 6c squared plus 1, 6c squared minus 1. All right, number 5. There's a GCF. So I'm going to factor out 7m. I can only take out one m and only one n. So that leaves us with m to the 6th minus 4n squared. And then we take the square root of m to the 6th, which is m cubed, because we divide by 2, and the square root of 4n squared, that's 2n. So for my final answer, we have 7mn, and then what's left in parentheses is m cubed plus 2n, m cubed minus 2n. All right, number 6. This one has a GCF of 10W. That leaves me with W to the 4th minus 1. So the square root of W to the 4th is W squared, and the square root of 1 is 1. So we have the 10W, W squared plus 1, W squared minus 1. But there's something you need to notice. This right here is another difference of squares. I have 2 perfect squares that I'm subtracting. So guess what? We have to break that down into difference of squares. Nothing else factors. Nothing else is a difference of squares. So when I factor it, I get W plus 1, W minus 1. Now this part right here that I'm circling, if you can solve these without having to write that down, that's okay. I don't have to see that. I do want to see a GCF if that's taken out. You know, I want to see that, but you don't have to write that part that I've circled. All right, next we're going to do sum of cubes. Now this one is similar. We have perfect cubes, and the word sum means we're adding, but the rule is a little bit more complicated. It's not quite as simple. So first off, let's look at our perfect cubes, and I'll just tell them to you and you can write them down. 1, 8, 27, 64, 125, 216, 343, 512, 729, and we can stop there. So if you ever want to know the cubed root, there is a way to do it in the calculator, but if I say, what's the cubed root of 125, you can just go 1, 2, 3, 4, 5, because you have that list there. That'll make it easier for you. Now, similarly, variables with an exponent divisible by 3 are perfect cubes. So, like the cubed root of x cubed, we divide by 3. That would be x to the 1st, or x. The cubed root of x to the 15th is x to the 5th, because 15 divided by 3 is 5. So, you know, kind of the same concept, but square roots divide by 2, cubed roots divide by 3. Now, here's the rule. If we have a cubed plus b cubed, so 2 perfect cubes that we're adding together. This is a plus b. So we're going to take the cubed root of each one to get a and b. And then we have a squared minus ab plus b squared. So copy that down. As we practice it, it'll get easier, I promise. So we need to take the cubed root of x cubed, which is x, and the cubed root of 27, which is 3. And so that's my A and my B in my formula. So then I have x plus 3. So going to my formula, A plus B is x plus 3. Then my formula calls for A squared, which is x squared minus. Then I have A times B, which is 3x plus B squared, which is 3 squared, or 9. And that's your answer. Sometimes you'll have a GCF. We'll get to those examples. All right, number 8. Number 8 is, we don't have a GCF, but we need to do the cubed root of m cubed, which is m, and the cubed root of 216 n cubed. Now, cubed root of 216, that's my 6th number over, so 6n. All right, so then we have m plus 6n. All right, then we have m squared minus, we multiply the two, 6mn plus, then I have the 6n squared, so 36n squared. And that's the final answer. Number 9, notice 504, those aren't on my list. So this is my hint, I probably have a GCF. And it's going to be 4. And when I divide by 4, we get 125 a cubed plus 1. Now the cubed root of 125 a cubed is 5a, and the cubed root of 1 is 1. Now we just got to throw it into the formula. 5a plus 1. Now we square the first one, so 25a squared minus, then we multiply 5a plus 1 squared is 1. Oh, wait. Guess what I forgot? I forgot the GCF. Don't be like me and forget, or you'll get it wrong. All right. Number 10. There is a GCF. For time's sake, I'm going to go ahead and tell you that the number part is 3. Let me scoot over. And then we can take out 1c and 1d. 8c cubed plus 125d cubed. Right, see if you can figure this one out. All right, so this time we have the cubed root of 8c cubed, which is 2c, and the cubed root of 125d cubed, which is 5d. Put it together. Got your GCF, 2c plus 5d times 4c squared minus 10cd plus 25d squared. All right. Now the last thing we're going to do is difference of cubes. These are almost identical to the sum of cubes. The only thing that's different are 2 of the signs. Pluses and minuses are flipped. So just to help you out, let's go ahead and rewrite in our cubes. Just makes it easier. And our rule, oops. All right. So this time it's a minus b, and then it's a squared plus ab, and the last one doesn't change. It stays plus. So the concept, everything is the same except for the minus and plus. So if you feel comfortable, just finish these 4. I want you to at least try them, and then you can fast forward to the end and check your answers. But I am going to go a little bit quicker. So if you feel like you don't understand, reverse back to question number 7 and maybe question number 8 where I worked a little bit slower. All right, number 11. So the cubed root of that is x, and the cubed root of that one is 1. So we have x minus 1, x squared plus 1x plus 1. Cubed root of this is 6k. Cubed root of this is 5. So we have 6k minus 5. And we have 36k squared. Then we multiply the 2 plus 30k plus 25. Number 13, we have to factor out a 4. The cubed root of that one is 1. Cubed root of that is 2h. So we got our 4 GCF, 1 minus 2h. Then we have 1 plus 2h plus 4h squared. And number 14 also has a GCF. Of 2. All right, so cubed root of this one is x. Cubed root of that is 3y. So we got my 2x minus 3y. And then we have x squared plus 3xy plus 9y squared. If you have any questions or you feel like I went too fast on these last ones, that's okay. Scroll back and rewatch. Sometimes just rewatching from the beginning of the process, it'll click. That's like if you watch the video and then you come back in and you're like, oh, that makes so much more sense now. It's more just because you're seeing it another time. And so sometimes it just helps to see it. All right? If you have any questions, don't hesitate to ask. Have a great day.